Hey everybody, welcome to episode 23, and this is the restore of the Hallicrafters 5R41 radio. So let me show you where we are, and of course, you know what they say, if you're going to hit a roadblock, you're going to hit a roadblock, so we have. So first thing you'll notice is I have the speaker mounted, and I put some cardboard and tape over it, because I don't want to take any chances of putting my fingers through that cone after doing all this work. So that part's good. And I do have the speaker. Let me turn this over so I can show you. I do have the speaker connected to the 3V4 tube right there. Okay, and I'm going to put a terminal strip here. This is the red side, which is going to go to my B+. So I haven't done that yet. But alas, we have a problem. And I'll explain to you what that is, and then I'll explain to you what we're going to do about it. So let me prop this thing up so I could show you. So, as you recall, I told you in a previous episode that on this couplet, I had every wire connected except for pin 7. Remember that? And pin 7 on this radio of the couplet actually goes to B+. So I started getting, let me pull back a little bit. I started getting ready to put a terminal strip here and getting my B+ here. And I was looking for the wire that comes from pin 7 on the couplet. And guess what? It's gone. So the wires are so fragile on that thing that the wire that was there snapped off. So you know what that means? First of all, it's right here. Right? See that? It's just snapped off. So that means that couplet's no good. I tried digging into it to see if I could find a piece of wire. Not going to be able to salvage it. Right? And you'll see right here, that's where I was digging. So, and in a way, I'm glad this happened now, because if that wire was marginal and I put the whole radio together and it didn't work, I would go nuts trying to find that. It would take me a lot of troubleshooting to try to figure that out. So, so this couplet's going to come out, and I was going to use that couplet that I built in the previous episodes, and I didn't really trust that, honestly. So let me tell you what I'm going to do about it. So let me put this aside. So I happened to be watching a video from our good subscriber, Sky Carl, and Carl was talking about building circuit boards. Right? He etched a circuit board with a Sharpie, if you remember, and you know, made it work. And I'm like, well, you know, that's something I'd like to try. I have a laser printer. So, so for me, it's something that would be a little bit easier because Carl didn't have a laser printer. He was using the Sharpie. So I took a look at this couplet. I'm going to zoom in a little bit. And I was like, okay, if I was going to design this couplet, how would I do it? Well, I would probably follow the same order as the schematic just to make it simple. I've really never designed one before. And I'm sure I can do it a much more efficient way. So my first pass was to go into my paint program and create this. And this actually is pin 9 and pin 5 and 4 and 2 and 3, and this is exactly what you see in the schematic right here. Okay? And I've got it all, I've checked it 100 times. These pads here that you see with the spaces between them, that's where the components go. And I've checked it, and it's exactly what I need. So I've printed it. But then I thought about it, it's a little too big. I'm never going to fit that underneath there. So I took that and I shrunk it, and I made it a little bit smaller. So there's a smaller version. So you'll see I've got all the same traces, and I've cleaned everything up, and this is what I'm going to do. So I ordered some ferric chloride, and I've ordered some of those one-sided copper boards, and when that gets here, I'm going to do exactly what Carl did. I'm going to take this, I'm going to put it on the copper, I'm going to iron it. I'm going to iron it until it sticks. I'm going to soak the copper with the paper on top in water, get the paper off, and then we're going to soak it in the ferric chloride. And we're going to see what happens. I've never done one before, but it'll be interesting. I can then take this completed board, run the wires out wherever I want them, basically, right, because this is going to be a one-sided board, so the wires are going to come up through the bottom. I'll put a piece of that big heat shrink tube on there, and I've got myself a couplet that I've designed on a small little circuit board. So the dimensions of the board are going to be something along the lines of 2 by 1 3/4, let's say. So that's how we're going to do it. So that'll be Thursday when I get all those parts and equipment that I need, and we're going to give it a shot. I've never done it before. Carl said he was going to put a video up, and I hope he does, because I want to see how he does it as well before I do it. But I've watched a few videos on YouTube, but you can never trust those things, obviously. But again, you take this, you put it on top of the copper. First you take the copper and you clean it, right? You scrub it, make sure there's no tarnish on it. Put this on there, put an iron on it until it gets really, really hot, and transfers the toner to the circuit, to the board. And when you do that, the paper is going to stick. You throw the whole thing with the paper in water, and you take the paper off, and it should be stuck to the circuit design. And you clean all that off, and then you throw it in the ferric chloride. And you probably need to leave it in there about 10 minutes from what I read. Don't know though, we'll have to find out. So that's going to be the plan for that. So we'll see how that goes. I also wanted to show you the 2 ohm wire round resistor that I'm going to use in place of that filter choke. So here it is. It's a 2.2 ohm wire wound resistor, 2 watts, which should be more than enough. This is exactly what I'm going to use in that spot on that in the radio, where it goes between the 3V4 tube, pin 1, and it goes to pin 7 on the 1U5 tube. So that's what I'm going to use in there, but I'm not going to install this yet because I've got to do that couplet deal, and I want to make sure I take care of that first. But once we get that couplet stuff all ironed out, we'll be in good shape. So I like doing it this way. Like I said, I already built one, right, if you recall, and I could use it, but I just don't, the way I did this is the one I built, and I don't know, the way I laid it out, I'm just not 100% sure, and I don't want to go through all this work of restoring this radio, putting this thing in and it being bad. So I'm not going to take that chance. By designing this the way the schematic looks, I'm pretty much assured that it's going to work, right? Like I said, I can run these wires anywhere. So that's going to be the plan. All right. So this will be this was a practice device here, this couplet. So that's the story, guys. I'll come back when I have another update. I'll be back. Okay, folks, so today the first thing we're going to do is we're going to make this circuit card. So I took a piece of the material, which is right here, and this is what you use to etch a circuit on. So one side is the green PCB material, the other side is copper, and I've cut it to size, so it essentially fits right over this pattern. Okay, and what I'm going to do is I'm going to print this on photo paper, on a laser printer. And then I'm going to take this, put it over the print, and I'm going to put a hot iron on it for about 10 minutes. And what that's going to do is adhere the toner to the copper. Okay? Then we're going to take it, soak it in water, get all the paper off of it because the paper is going to be stuck. And then we're going to put it in some ferric chloride for about 10 minutes. And that should create a nice little circuit board. So I'm going to go do that, and I'll show you the steps along the way. By the way, this is the sheet that it comes in, just like this. This is about the size. I just cut it with the Dremel tool. Okay, I'll be back. Also, one other thing, after you do that, you have to rough it. You have to basically polish it with some 800 grit sandpaper because there is going to be oxidation on the copper. I would suggest you do this right before you print on it or transfer it because it's going to oxidize. So you give it a nice little bath and then you do the process. Be back. Okay, so basically we have our piece of copper with our paper on top. I have it on a bamboo cutting board. And I'm simply just putting a piece of paper over it. I've already done this for about 5 minutes. And I'm applying a hot iron right to the material. And we're going to move it around a little bit. I'm going to leave it there for another couple of minutes. I think we're pretty close. It only takes about between 5 and 10 minutes, I think, to adhere. So we're just going to leave that on there. We'll move it around a little bit. And I'll come back when that's done. Okay, so our piece is done, and we're going to now take it and give it a bath in some water. I'm going to let The water soaked that paper up. And when we take the paper off, what we should see is a piece of copper with black lines all over it. Dark lines. We'll find out. We're going to let it soak. So I'll come back when that's done. Alright, because I like to also show the mistakes and the successes, you'll see here that I got good adherence on this side. Over here, not so good. You can see those traces are just not good. So we're going to cut another piece, and we're going to apply more heat for longer, because I don't really know the exact amount of time. And we're going to try it again. I'll be back. Okay, here we are. We're going to try again. We've printed a new piece on photo paper and a new piece of copper, and we're going to apply some heat. So let me do that. I'm going to give it 10 minutes this time and see what happens. Be back. The other thing I'm going to do this time is I'm not going to move the iron around as much. If I keep it centered like this and just stationary for a bit, it's going to, I think the heat's going to transfer a lot more evenly. So we're going to keep the pressure on here for about 5 minutes, and then we'll move it around. All right, be back. I've also put the iron on linen. I had it on wool, but I think linen is the hottest setting. So we pump that up as well to the hottest setting. Okay, a few more minutes left. Okay, we're just at about the 9-minute mark, and I'm going to just give this another 30 seconds, and then we're going to pop it up and throw it in the water and see what happens. Now, the big difference on this one that I didn't do on the first one. The first one I used regular paper. I wanted to try it, and I thought about it that regular paper wasn't a really good quality, so you probably wouldn't get a solid, good trace. Using photo paper, I think is a better deal. So this one is photo paper. So I think we're going to take this up, see what we got. There's our piece. Very hot, should be. We're going to take our water. I'm going to let that cool down for just a minute. I don't want the copper to warp. I don't know if it would or not, but who knows. Okay. Let's get some of this paper out of this water. Okay. Alright, we're going to take our piece and give it a bath and see what happens. There it is. We're going to let that soak. I'll come back when it's ready to be peeled. One thing I noticed about this photo paper is it doesn't break down as easily as regular paper, obviously. So I've replaced the water with some warm to almost hot water. And I want to see if that makes a difference. I could see right here, in that spot, it's starting to break down. It just takes a little longer, so you have to be patient. Okay? We'll be back. Alright, so on photo paper I had to peel it off. Alright, that's what I did here. And you'll see it looks pretty good. I have one area that I'm concerned about, and it's right in this corner. And I'm going to see if I can get close to it. I'm not sure if that's a break or if it's just a little bit weak. So I'm going to go ahead and put this in the ferrous chloride and see what happens. Then I'll just test the conductivity around. And if I have to put a piece of jump wire, I can do that. That's no big deal. But I'm going to let this soak just a little bit more. There's a piece of paper stuck right there. And then I think we're ready to see if this thing works. Okay? I'll be back on the next step. Okay, here's the ferric chloride that I'm going to be using. And I want to remind you of a few things if you ever try this. This is an acid. So you have to use gloves, and you don't put your fingers in it. You got to use a tweezer or something like that. So let me get this started. Be back. Okay, we poured some of the ferric chloride. And we're going to take our card. We're going to put our card in face up, like so. And we're going to help it. We're going to move it a little bit, agitate it. Now I understand, I could actually see it starting to work already. I believe that we need to leave this in here for about 10 minutes. But we're gonna keep an eye on it and agitate it, like so. Now when this is done, what you should have is a piece of green circuit board with black traces. And then what we're going to do is we're going to take some acetone and we're going to clean off those black traces, which is the toner, And that should reveal our copper traces. We'll see. Now, if you were doing a double-sided board, which you can do, they do sell these things which are double-sided boards. You know, you'd have to do it on both sides, obviously, and you'd have to flip this thing over at some point. But this is only one side, so that's good. I'm going to give this a chance to work. All right, so I'll stop the camera here and come back when I've got a little progress instead of making you wait. Be back. By the way, it does say on the bottle that if you heat the solution, it will accelerate the action. But we're not in any rush here, and I don't want to start heating up a chemical like this. So we're just going to let it take its time. No rush. We're still agitating. I can start to see the edges are disappearing already. Be back. All right, we're still waiting. It's about 5 minutes or so, and I could see it slowly starting to work. You got to remember what this stuff is really doing is just eating away the copper. That's all it does, right? This is a piece of board, circuit board, which is a epoxy resin, I think, or something, and there's a coat or a very thin layer of copper on it, and all we're really looking to do here with this acid is melt the copper that's not exposed, or that is exposed, I should say, and the copper underneath the toner stays. So we're going to let this keep working. The temperature of the product is probably around 75. It says you can heat it up to approximately 135, but again, we're just going to let it work. Okay, we'll be back. By the way, you should use this product in an area that's well ventilated, obviously. I'm not smelling any fumes coming out of it, but if you mix it with other chemicals, it could be extremely toxic. So, again, got to be careful. If it wasn't so cold out, I'd probably be doing this outside. But I don't smell any fumes coming out of this. But don't get it on your hands. That's why you have gloves. Okay, so one change I made here is I took this metal pan and I put some tap hot water in it, and I'm just soaking the solution there to speed it up a little bit. I do see it starting to work. It's slow but sure here. And it does say on the bottle that you need to keep agitating the solution. So we're going to keep doing that. I'm starting to see some good progress. So I'll be back in a minute. Let me show you what we have here. You can start to see that see that green around the edges there? See that trace right there? Means the copper's coming off. That's good. We're getting there. And I'm pretty sure when this is done you can reuse the formula, put it back in the container. You gotta remember, all this ferric chloride really is acid with rusty nails in it. That's what they do. They put rusty metal parts and acid and a little peroxide, I think, and that's how you get it. So all we're really doing is breaking down metal, right? I don't know if I'll save it or not, though. I have to think about that. I'm not even sure how I would dispose of it, but I'm not going to worry about that right now. We're getting real close here, by the way. Looks like it's about maybe about 60% done. So let's go in the home stretch here. Okay, I've just taken the board out, and you'll see that the copper's gone, and it looks like we're ready to go. I'm going to let it soak for just another couple of minutes, just to make sure that that it's all gone. It's not going to hurt it. And then we're going to take it and rinse it, and then we're going to use some acetone to get rid of those black lines and expose the copper. And then we'll get our meter and we'll do a conductivity test. Okay? So just another few more minutes in the drink. Be back. Okay, I think we're done. I think we're just going to let that drip a little bit. You'll notice that the forceps that I'm using are also discolored from the chemical. Right? It's taken off the shiny finish. We're going to let that drip another minute, and we're going to give it a nice rinse in some cold water. But I'm really satisfied with this. I'll be back. Let me give you a close-up without it dripping. There you go. Pretty cool, huh? Okay, our board is all rinsed off. Let's go get the acetone. Be back. Okay, so we're going to use some pure acetone. And I have a lint-free rag here. And we're going to start to rub off that toner. Let's see what happens. Look at that. that cool or what? Wow. Yeah, remember guys, this is the first time I've ever done this. Okay. Put the cover on this chemical here, this acetone. Look at that. Very cool. Just by doing a quick inspection, the area that I was concerned about, which is right here in this corner, does appear to be a problem. Let's see. So we can zoom in. See that corner there? I'm going to have to put my meter on there and see if I get a connectivity. If not, I can just solder a little drop of solder on there. We'll fix that. A little solder bridge. It's not perfectly clean, but I've got enough copper that I could definitely adhere some solder to. Very interesting. There's probably some other techniques I could have taken here to make this a little more cleaner. I probably should have sanded the copper better when I did it. Maybe, who knows? But I'm going to go ahead now and test all this out with the meter, and then I'll drill the holes so you can see where the holes need to be. And I'm just going to use a Dremel drill press to do that, and I'll show you that when I do it too. But here you have it. We have a circuit board. Very, very cool. Okay, I'll be back. Okay, this may be a little boring for some of you, but we're going to test out the connectivity. So we're going to start in this corner. This connection comes all the way back to here. That works, and it should go here. So it looks like I don't have a break there, which is good. Okay, I'm going right through that corner. I don't know if you could see it. I'm coming up to here. Good. This trace here goes to this pad and that pad. This trace here comes here and here. Good. These two are connected together. These two are connected together. This pad and this pad are connected together. Here, here, here and here. Good. Let's check this again. Good. This pad comes all the way up across to here. Excellent. Anybody want a bird? Excellent. 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 So we've proven that the board is good. We've got our connectivity. Awesome. Okay, next step is going to be drill the holes, and then we're going to have to put some kind of clear nail polish or something on those traces because they are going to oxidize again. So we got to make sure we put something on there to protect them. Let's get to drilling. Okay, here's our Dremel drill press, and what we're going to do is we're going to mount one of these bits on here. And I'm using relatively small components, but I'm going to use the biggest bit, which is this one right here. So let me get that mounted. Okay, this is a little bit of a challenge for my old eyes, but we're going to give it a shot. Cool. Okay, you get the idea. Let me get the rest of these done. See those holes? Cool. Let me get the rest of these done. I'll be back. As I do the last couple of holes, if any of you have a Dremel, I would strongly suggest you get a drill press like this. $39 on Amazon. Okay, I think that's our board. There it is, in all its glory. Pretty cool. I'm really happy with this. So now we're going to mount the components, and I'll do that in the next video because this one's too long. We're going to mount the components. We're going to put all the wires that we need on there, and then we may drill another hole here and mount it using a terminal strip, but we'll see about that. And get this going. So I hope you learned something from this. See you guys in the next episode.